Yeah, some whistles. 안녕하세요. Hope I didn't butcher that too bad. Okay. I'm Ben from Starkware, and today I'm going to be talking about StarkNet Account Abstraction. Okay, so account abstraction on StarkNet. There's some caveats here, but for the most part, accounts on StarkNet are just smart contracts. So the more we dig in today, and like Erica said, we're going to get a little technical, and it is going to be a little bit of a workshop. But for the most part, accounts on StarkNet are simply smart contracts. So that's the model I want you to have in your head as we go through this talk. One of the caveats, and there are just a few, is that the entry point selector on the smart contract needs to have a function denoted with an execute function, with the underscores in front and the underscores in back. I'll show you a little bit why, but by and large, to keep a simple framework in your mind, accounts on StarkNet are simply smart contracts. So let's briefly look at some Cairo code. Just out of curiosity, raise your hand if you're a developer. How many developers do we have in here? Okay, cool. And how many people have written a line of Cairo? Nice, okay. So for a lot of you, this will be the first time looking at Cairo, and it might be a little difficult to parse, but I'll just point you to line 11. That's an external function that's called by other smart contracts, and like I said, it has the canonical entry point of execute. So double underscores in front, double underscores in back, and that notifies the StarkNet OS that this is, in fact, an account. The other line I want to point you to is line 14. So what is the purpose of an abstracted account contract? It's really so that we can call arbitrary functions on other smart contracts on the composable network, but know it's from a known party, and that includes a signature. So we'll go over signatures in a little bit. But on line 14, we're basically calling another contract from this contract and passing along the call data, which is an array. So don't worry if you can't read that, but the most important parts are the execute function name and the call contract, syscall. So besides the StarkNet OS, there's one other piece of tooling that needs to be aware that this is an account, and that's the compiler. So when we compile this account contract, we need to pass the flag for account contract. So a normal StarkNet smart contract will not be compiled with this account contract flag. Okay, so you've seen basically the simplest account contract you can possibly have, but why do we want account abstraction? What's the purpose of it? One of the benefits of not being the first mover in a smart contract platform is that we get to kind of see the way the developer tides ebb and flow, and it turns out Ethereum actually has a strong push to implement account abstraction. So if you want to know a little bit more about that, go to EIP 2938 or at EIP 4337. You can see some of the history about account abstraction and attempts to implement account abstraction on Ethereum. But it definitely seems like devs are clamoring for account abstraction. So this is from Vitalik. The fact that Ethereum protocol itself requires everything to be packaged in a transaction originating from an ECDSA secured externally owned account, EOA, makes account abstraction very difficult. So one thing you get if you're a developer coming to Cairo, coming to StarkNet, is you get account abstraction right out of the gates. But again, why do we want it? Why is this a good thing? One thing is better wallet UX. So crucial piece of infrastructure, wallets. On the right side are a couple of the wallets on StarkNet. So Argent X is probably the most used right now. Bravos is kind of a new player. They're awesome UX. I recommend checking them out. Magnity is one. And then Laura from Consensus spoke about snaps. So there's actually a beta snap that is a POC right now, I believe. I don't know if Laura's here, if she left. It's in beta, and basically MetaMask will be able to support StarkNet signatures and accounts. So why do we want account abstraction for better wallets? So better wallets, what does that mean? You can have alternative signature algorithms. So being an EOA, controlled by a public-private key pair, you are regimented into the, I think it's SCP-256 K1, yeah, K1 signature algorithm. So if you have account abstraction, you can start playing around with other signature schemes, really any signature scheme. You also can get upgradability. This is something that ArgentX has already integrated. So since it's just an account, you can upgrade it like any other account. It can have a proxy in the back end, and you can implement new logic. Social recovery, key management. A lot of the Ethereum communities, I know Vitalik talks highly about social recovery. ArgentX specifically has a guardian setup. So if you have maybe a couple close friends, you can add as guardians, and they can vouch for your social recovery. That's just not possible with an EOA right now. Session keys for gaming. We'll get into session keys for gaming a bit, but the concept is basically, what is the UX for gameplay? If you have to sign each and every transaction and each and every state transition in your game, think about that through MetaMask. You're literally having to open MetaMask and click sign for every single transaction as they propagate through your game. So there's a concept of session keys, which basically is one authorized key that will give you a certain amount of authorized access for signing transactions over a certain amount of time. Multi-sigs, we all basically know what multi-sigs are, but multi-sigs become really easy in an account abstraction model. We'll look at that. And paymasters. So on StarkNet, anytime an invocation transaction is called, there needs to be a fee paid. And what is that fee? That fee is the L1 footprint of that transaction. So how much, and then also how much compute it was to execute the transaction. So paymasters, you can think about architectures in which a third-party account or a third-party contract pays the fee for the invocation transaction. There's lots of different use cases where that might be helpful. So payment abstraction. Not only can we go with different models for transaction payments, in the Encode Club hackathon in Paris, there's actually an NFT team who wanted to basically have an NFT with all of the NFT functions being paid for by a larger account abstraction account. Transaction payment made by the third party, so we talked about that, and then wallet to abstract the fee token. So at the base layer of the protocol, the token that will be paid in fees will be the Stark token. But if that is not the most user-friendly for certain DeFi applications, you can probably imagine, the account abstraction can basically abstract away which fee is being paid at that call level. So really what it is flexibility for the developers. We're not boxing in any of the developers. With all of that flexibility, though, we require some sort of standardization. So because you can have an account contract that implements arbitrary smart contract logic, how do we, as the community, know which account contract to kind of band around, to use? So we need standardization. So OpenZeppelin has created a slew of Cairo Code for us, and it's really helpful for things like reference code. I recommend you to go look at Cairo contracts source OpenZeppelin account. That's the subdirectory tree there. You can see how they implement it. But why do we need standardization? Because all of this flexibility, basically, there needs to be some set of accounts that we all know that we're using. Some set of call data layout that we know that we're passing. Some sort of base signature implementation that we know we're signing with. And then the last reason why we're implementing account abstraction is to empower the devs. And this is really the most important thing. We're dealing with a design space at this layer 2 level and eventually layer 3 level. I hope you guys got to hear Ellie's talk this morning, but some pretty incredible stuff happening at layer 3, empowered by recursion, which went live today. You guys got the alpha. So it's just a completely new design space. So why would we limit the subset of designs for wallets, for all these things, to just a single public-private key pair? And a lot of the things we do at Starkware is to empower the devs. So one of the things that got me into the Starkware ecosystem is the optionality that it gives. You know, you can start playing around with volitions, validiums, and now you have you can play with account abstraction, you can play with StarkX, StarkNet. Really, if you have something in mind, you can basically implement it in whatever way you want on StarkNet or StarkX. So how to implement account abstraction? Quite a few of you are devs, so if you want to follow along, you should be able to. But we're going to look into some code here. Signing. So how do we sign and where do we send the signature? So the basics of signing are, and again, I'll preface this by saying this can be implemented in however the developer wants it to be implemented. But what I'm going to walk through is the basic implementation and probably what you're going to see as the default implementation in a lot of smart contracts, especially those Open Zeppelin reference code smart contracts. So off-chain, you're going to hash the transaction data probably with the Peterson hash. The Peterson hash is a Stark-friendly hash, which we use all over the protocol. You're going to sign with a private key. This is going to be a private key derived from the Stark curve, and that Stark curve is the basis of, again, a lot of the protocol. Submit the transaction with the signature in the signature field array, which is an array of felts. We don't need to dig too far into felts, but felts are the base scalar type for Cairo. And then verify with the stored public key of that ECDSA signing pair that you generated for the account. And then on the right side, you'll see a pretty stock implementation of a signature verification. So when we pass the array of felts into the smart contract, we basically just say, is this hash that we generated in the first bullet point there valid? And then at the code block below, this is how you declare a storage variable in Cairo and StarkNet. And if you see on line 12, this is completely an implementation detail up to the developer to call this variable public key and store the public key in the smart contract storage of the smart contract. And then again with the nonce, so you are pretty much always going to see a nonce with an account contract, so you don't get any duplicate signing. But again, this is an implementation detail that's up to the developer. Multi-call. So we've seen signatures. You can basically apply that concept of signatures to everything I'm about to talk about. Even though it's an account contract and a lot of the stuff is abstracted away, you're always going to want to have some signature of some off-chain party with a private key signifying that they did indeed agree to whatever the terms of that transaction is. So multi-call. Multi-call, you can batch contract calls in one invocation. You can reduce the number of separate RPC calls and create atomic invocations. One of the cool things about Argent X specifically, and a lot of the account abstraction models on Ethereum, is that they actually by default implement a multi-call, and then if you only have one transaction that you'd like to put on the network, it's still just a multi-call of one transaction. So think back to the original Hello account abstraction, the simplest account abstraction we had. What was passing in was a call data, and we were calling a single address on StarkNet. So if you look at this one on line 107, we're passing in an array of arrays of call data. So now we can pass in multiple calls for multiple contracts. Multi-Sig, we talked about Multi-Sig briefly. Super important to the DeFi ecosystem. You don't want to be trusting a contract with one person managing one private key. So we have a share of security across signing entities, and a lot of the different configs in the construction of Multi-Sig, so 2 of 3, X of X. A lot of this implementation is easier with account abstraction. On the right is some of these functions are collapsed, but it's kind of the base of what a multi-call looks like. And again, this is just a few developers have this stubbed out. If you have a different idea for a multi-call, a different idea for a multi-sig architecture, go build it. So constructor is a call once function in Cairo and StarkNet. It's basically how we init smart contract storage and smart contract configs. So this is an example of a 2 of 3 multi-sig, and you can see that with the assertion of 3 owners and 3 public keys. So if you have 3 owners and 3 public keys and 3 signers, one of the signers will submit a transaction, at least 2 of the others will confirm it, and then we can execute it. And again, you see the execute canonical entry point there at the bottom, which is what you need to be an account contract. So example of account abstraction. this was done at our DevConnect hackathon in Amsterdam by some community builders, Brick and Realms. And if you think back to session keys, this is what they've implemented. And again, like Ellie was saying, you know, the ethos that we put out as a company is really, you know, not super heavy on marketing, but super heavy on shipping code. That the community has basically inherited that. So we you know, this is a feasibility and something that you can be done with account abstraction. And guess what? In I think 2 days, this team went out and did it. So the problem statement: how can you play a high frequency game on chain? And the solution they came up with was ephemeral session keys. They created a one-time key stored in browser. And then for playing Stardew Valley, this is the transaction makeup that they decided to outline. They needed transaction data for the timestamp and for the X and Y coordinate of the plant that they planted in-game. So you can imagine how cumbersome that looks like if you need to sign every single plant that you plant. Well, they have the one-time key stored in browser, and that key has been authorized for a certain amount of time. And now the user signs only one transaction for the game session. They did it, and I think it was 24 hours. It might have been 48 hours. So they have some potential upgrades that they can make to it. A spend limit. So one key might have a certain amount that it's capped to spend. Function call restrictions. So you can imagine a smart contract wallet that only allows certain keys to call certain functions. You basically get into all the slew of different configs for what can be whitelisted, what can be permissioned, or you could go with the base level multi-call and more. And so that's kind of the point I want to drive home, is that, you know, these smart contract account abstractions enable you to do anything. So here's the workshop. We're not able to live code, but I've taken some screenshots. So hopefully, if you do want to follow along, feel free to. Check out StarkNet edu on GitHub, and then this is the repo for StarkNet Accounts. You should be able to code with, but if not, no worries. If you're trying to catch up with this after this workshop or after this talk, there's a README in StarkNet Accounts that you can go through. Has all of the same information, so you'll be able to hopefully go line by line and see how to run this workshop. So the environment for developing Cairo looks like this. In setup env, you need a Python virtual environment, and you need to activate it. We're going to install the requirements. So the requirements for this tutorial are the Open Zeppelin Cairo contracts, which we talked about a bit. It is the Cairo language itself, including StarkNet and the StarkNet DevNet. So for devs, I recommend this cadence, and you've probably seen this cadence in other places, like if you're a Solidity developer. But if you look at the bottom, unit tests first, then deploy to DevNet, then deploy to testnet, then deploy to mainnet. So things like testnet and things like mainnet, even though they are fast, and even though they are getting faster, especially with certain implementations in Rust and certain other scalability techniques we're employing, they are still slower than running on your local machine. So let's say you're Solidity dev and you use Ganache, that is going to be comparable to the DevNet. So check out the DevNet. Again, it's in the README. But the typical development cadence I would suggest is unit test, DevNet, testnet, mainnet. So after we installed the requirements, we initialized the DevNet, and the line for that is there, StarkNet DevNet on port 5000 with seed 0. Because we initialized the DevNet with a 0 seed, we get a deterministic pre-deployed accounts, which means that we know the public-private keys and addresses for all of the DevNet accounts, which means we can start playing around with it. The DevNet pre-deployed accounts come with a certain amount of Ethereum, so we can start to pay gas fees with them. Like I mentioned, any invocation transaction, any transaction that alters state is going to cost money, and it's going to be the L1 footprint of that invocation transaction. So we do need, that's why we need the seed 0, is because we need some gas money, basically. Okay, so now we deploy the evaluator. So the way that this workshop and actually all of our workshops in StarkNet EDU are set up is there's an evaluator. So you go out and deploy these incremental steps in this learning. So multi-call, multi-sig, account abstraction with a SECP 256K1 signature. So that's the Ethereum signature. And we have an evaluator smart contract that goes through and says, yes, you did indeed sign a transaction how we specified you to sign it. So on DevNet, this is how it looks. You just do Python 3 evaluator.py on DevNet. And if you did the previous step of initting the DevNet, you should be good to go. And you should see some smart contract addresses start populating for the registry, ERC20, and evaluator. If you've done everything correct, if you've implemented all of the smart contract logic as we've stated, then you will get paid in the ERC20 that you see there, which is not worth anything, but it's fun. Okay, so next step is to deploy the contracts. So we've deployed the evaluator, so we know if you've done the exercise correct or incorrect. Now we'll deploy the actual exercises. So Python 3, hello, hello, Pi. At the very top, you'll see the mission statement for what we're looking for you guys to do. We're looking for you to deploy an account with a contract with an execute entry point, like we've talked about. Fetch a random storage variable from the validator contract, and then pass that random storage variable in call data to your account contract. So now we start working through basically all the steps that we talked about. Why does the smart contract need to be funded? To have gas to cover your invocation fee. How do we call another contract on StarkNet? Yeah, and if everything went right, you'll see an emitted event for payday, and you should get paid in absolutely worthless ERC20s. Again, just a reminder at the bottom, unit test, devnet, testnet, mainnet. This should come as no surprise to developers. You need to step through some sort of cadence before you feel comfortable deploying to either testnet or mainnet, really. Yeah, one more thing I'll say is that there is if you get confused about this repo, if you are going to go through this accounts contract tutorial, there's a branch of this repo called hints all. So, some of the requirements that we're looking for are a little esoteric. Some of them require you to implement 2 lines of smart contract Cairo. Some of them require you to do about 30 or 40. If you're confused, if you want to look at some hints, go to hints all, and it'll show you what a passable contract looks like. So here are some useful links. There was only a small subset of hands for Cairo, so if you want to get started with Cairo, check out StarkNet EDU. There's a couple other repositories in there for ERC20s, ERC721s, bridging, so we're a layer 2. StarkNet is the layer 2. If you need to know how to bridge to and from ETH1. And then Starklings. I highly recommend Starklings if you're getting started with Cairo. Some of you might be familiar with Rustlings, but it's a dynamic, test-driven way to start learning the language. Resources, so I recommend Awesome StarkNet. This is where you're going to find libraries, SDKs, documentation, tests. I go there for when I'm basically looking for anything. Docs, so cairolang.org/docs is where the docs are for Cairo, and then docs.starknet.io for StarkNet specific. So when you're writing a smart contract on StarkNet, you are writing a subset of Cairo. So you can actually do a lot more things with raw Cairo, and that's why those 2 documentation sites are split out from each other. Community, we'd love to have you guys involved. We have kind of a budding, booming community, so community.starknet.io. Come chat with us. And yeah, thanks. Appreciate your time.